Hello everyone, and welcome to this series about machine learning using TensorFlow. This is the first episode and it's about machine learning basics. Before we start, I would like to tell you about the new show that's gonna be on this channel. It's called the Unsupervised Show. It's a talk show with the professionals in machine learning and AI. So if you're working on anything interesting or you know someone who's doing something interesting with AI, machine learning and robotics, please leave a comment in the comment section underneath this video recommending them, or you can contact me on Twitter. So let's start this tutorial by asking why are we talking about TensorFlow. TensorFlow is Google's framework for developing machine learning models. It has emerged as the most popular machine learning library. Since 2011, Google Brain Teams has been developing TensorFlow, and it was used internally inside Google. It was released as an open source software in November 2015. It comes packed with a wide range of tools, from dataset management to a good selection of high-level algorithms, and even ready-made algorithms and web-based dashboard. That's a lot of things to pack in one solution. The team that's working on developing TensorFlow are some of the most influential researchers in machine learning. There is also a huge amount of contributors and commits that's for relatively a new project on GitHub. You quickly realize that TensorFlow is getting more attention from people in the field than any other existing machine learning solution, and it will be the technology standard for machine learning. The reason for that is the support, so many things, but first of all, OS support. It supports so many operating systems, including Linux, Windows, Mac OS, Android, and iOS. So it even supports mobile OS. Programming languages. It has APIs for many programming languages, including Python, C, C++, Java, and Golang, and other languages actually. Hardware. It can run on CPU, it can run on GPU or TPU, which is a Google hardware that is designed to process machine learning algorithms. It can even run on distributed systems where you have a cluster of computers or so many GPUs, and you can distribute your work or load balance it over multiple machines. There is also TensorFlow.js version, which runs in a browser on the client side, so no need for a backend. So basically, you download the model on in the browser, and it runs without any backend for it. There's also TensorFlow Lite, which converts machine learning models to a format that can run on mobile devices running iOS or Android. Within 2 years of its release, TensorFlow has been downloaded over 11 million times from almost every country on Earth. So what is machine learning? Before we dive any deeper in TensorFlow, I would go over some basic concepts of machine learning. This tutorial is for developers who can develop in Python but not well versed in machine learning, or familiar with some other machine learning libraries but new to TensorFlow. It's also useful for non-developers working in other fields like statistics, medical field, marketing, or even social studies, and eager to experiment with machine learning in their fields. Machine learning, ML, is a branch of artificial intelligence, which is AI, a very common term you will hear a lot in this field. It uses data instead of code to produce logic. The goal is to create software that can perform tasks that we usually equate with human level intelligence. In some cases, it could exceed human level intelligence, like what happened with the AlphaGo and some other examples. You actually use machine learning all the time without realizing it when you use Google, YouTube, Amazon, and so many other services that rely on machine learning to give you a better experience. Machine learning is built on algorithms that use data to train models to perform tasks. So let's meet Tensi. This is our friend Tensi. He's a robot eager to learn and solve human problems. You can follow him on Twitter at TensorRobot. So you can think of an algorithm as the device that teaches models. So it's like the teacher. The algorithm is the teacher. The robot is your model, and the material that you're teaching your model is your data. So the algorithm takes data and takes the model and trains the model to do a specific task. Learning styles. Models can learn in 3 styles depending on the training algorithm. There is supervised learning, or SL. Supervised learning is teaching a model to give output based on some input. The algorithm teaches the model by giving plenty of examples and their output. There are 2 types of problems that can be solved using supervised learning, which are first, classification. Classification is used to teach a model to output a category or a class based on some data point or some input. Like learning if a photo has a cat or a dog. So I want Tensi to learn how to tell cats from dogs. We can give Tensi photos of cats and dogs until it learns to tell a cat from a dog. I can later test him on new photos that he has not seen before to see how accurate he is. So in here you can see Tensi going over photos of dogs and photos of cats, trying to find patterns and trying to find the difference between cats and dogs. And by the time it finishes going over these piles of cats and dogs pictures, it should learn how to tell if a picture has a cat or a dog. The next problem that we can solve is regression. Regression is used to teach a model to output a continuous number value based on a data point or some input, like telling the age of a person based on their photo. This time we are teaching Tensi to tell the age of a person based on their photo. To do that, we will give him a large amount of photos and tell him the age of each person. We can later test him by asking him the age of a person in a new photo that he did not see before. So in here you can see he's going over photos of people and trying to see the age of each person in each photo, and eventually it will learn how to tell or guess basically, or predict the age of a person based on their photo. The second style of learning is unsupervised learning. Unsupervised learning teaches a model to produce an output based on data point or some input without teaching the model the output. Like giving a model photos taken outdoor and photos taken indoor, and ask the model to split them in 2 piles. There are many problems that can be solved with unsupervised learning, but the most common ones are first clustering. So clustering is grouping similar data points into groups or clusters. Different algorithms can find similarities in different ways. You can end up clustering your data points into different groups. Some of these algorithms need you to tell them how many clusters do you want to split your data into, and some will try to figure that out on their own. So they will figure out how many groups are there in your data. This time we give Tensi a group of photos, random mixed photos in here, and we ask him to split these photos into 2 groups. He will find that all indoor photos are similar and all outdoors are similar. So this is the input, and Tensi is trying to figure out what's the similar photos in here that he can split into 2 groups, and it will end up splitting all the outdoors photos separate from the all indoor photos. Other unsupervised learning algorithms can solve some interesting problems like anomaly detection. Anomaly detection is used for so many purposes, but let's say you want to monitor logs and you don't know what you're looking for, but you want anything that's out of the ordinary. So that's a good use for that. Generative adversarial networks, or GANs, they're mostly used to generate photos. So we can generate a photo of a bird, for example, that the model did not see before. It will generate a new photo of a bird. The final style of learning is reinforcement learning. Reinforcement learning uses an algorithm to teach a model to produce a desired output based on without explicitly explaining how to perform it. This works by giving the model an output and rewarding a good outcome and punishing bad outcome. This is similar to how humans and animals basically learn. Let's teach Tensi to play some Atari games. The input of the screen feed from the game. The input is the screen feed from the game. So it will see the screen of the game and it will evaluate that current state. After each frame from the input, it will be able to choose one action. So it will choose up, right, left, up, down, or and press or not press the action button. That action might lead to increased score if it was good action, or to no increase in score if it was like a neutral action, or it could also lead to losing a life in the game and losing some score. So for bad actions. So as it sees the screen of the game, it will evaluate that current state and it will choose to do one action. That action will go into your environment or your console in here, and that console will give it a reward, which is the current score of the game. So whatever increases score, it will be the preferred action to do based on some state of the game, or where are you in the game at that point. Machine learning is more than that. These major categories are not inclusive of every algorithm that you might use. Some evolutionary algorithm or recommendation systems do not fall under any of these categories. Some more complicated algorithms use multiple stages in a pipeline, some with supervised and unsupervised learning basically. So your end-to-end algorithm might also not fall under any specific category, or sometimes it will be called semi-supervised. The math behind it. This section will explain some mathematical concepts at the end of each tutorial. These tutorials are going to be code intensive, and that will help you develop your coding skills and get your model working. But what if it doesn't work? The math behind these algorithms use linear algebra, tensor calculus, and statistics. These are not easy topics in mathematics. They are complicated topics in mathematics. This section in each tutorial will explain the math behind what we discussed, and will assume very little to no math background, and will explain things from the ground up. This could help you fix your model or even improve your accuracy. Finally, it will serve as a bridge between machine learning concepts and centuries of mathematical research. Mathematics is the language of science, and learning this language will open the door for you to explore some of the latest academic research papers in machine learning, due to the fact that they mostly look like this. So this is a small section of training a paper called A Training Algorithm for Optimal Margin Classifier, published in 1992. This is a really famous paper, also known as the original SVM paper. SVM is a famous classification and regression algorithm. To kick off this section, we'll start with a few simple concepts. So let's start with real numbers. Real numbers include positive, negative numbers, and zero. They can be of any arbitrary precision, meaning they can have any number of decimal points, or even numbers with infinite precision, so an infinite number of decimal points. The set is denoted in mathematics as R, this bold typeface R. Examples of real numbers include 5.0, minus 2.5, 1 over 3, or 0.333, infinite number of threes, or pi, 3.14159, or Euler's numbers, or number, or E, which is 2.71828. The next thing that we'll talk about is sum. So to represent a finite sum of numbers in mathematics, you can use the following. So 1 plus 2 plus 3 plus 4 plus 5. For longer sums, like getting the sum of all numbers from 1 to 1000 can be harder to write in that way. We can we use sum, denoted in mathematics as the capital letter sigma. So this is the capital letter sigma. To rewrite the previous equation from 1 to 1000, so all the numbers from 1 plus 2 plus 3 plus 4 until 1000, using sum you can do this. Sum of n equals 1 to 1000 n. So it will generate all the numbers from 1 to 1000 like a loop, and it will add pluses between all of these numbers. So it will be 1 plus 2 plus 3 plus 4 until plus 1000. This can facilitate writing more complex functions like this. So f of x equals x plus 2x plus 3x plus 4x plus 5x. We can rewrite that as sum of n equals 1 to 5 nx. With this notation, we can even represent an infinite sum of numbers. Something like 1 over 1, which is basically 1, plus 1 half, 1/4, 1/8, 1/16, and it goes to infinity. We can rewrite that as sum of n equals 0 to infinity of 1 over 2 to the power n. So you can start it with 0, 1 over 2 to the power 0, which is 1 over 1, plus 1 over 2, plus 1 over 4, plus 1 over 8, plus 1 over 16. And one cool mathematical fact, this series is actually equal to 2. The other thing we will talk about today is product. To represent a finite product of numbers in mathematics, you can use the following: 1 times 2 times 3 times 4 times 5. For longer products, like getting the products of all numbers from 1 to 1000, you can it can be harder to write it in that way. We can use product denoted in mathematics as capital letter pi. So this is capital letter pi. To write the previous product from 1 to 1000, we can write it in this way: product of n equals 1 to 1000 n. Note, it should also be noted that the previous product can also be written as 1000 factorial. It can factorial is represented by an exclamation mark, so which is basically 1 times 2 times 3 times 4 until 1000. This can facilitate writing more complex products like f of x equals x times 2x times 3x times 4x times 5x, which can be written as product or a product of n equals 1 to 5 nx. This tutorial is available on GitHub. The link to this is in the description down below. Feel free to use it for any purpose you want. It's open source. And if you liked the content of this tutorial, I hope you subscribe to this channel. And if you really like this tutorial, I hope you will buy one of my t-shirts. I have the iTrain t-shirt showing Tensi going through training using an algorithm. It's called iTrain. You can watch the next episode of this series, and it's going to be about tensors. And if you want an introduction to Jupyter and Python in general, you can go over my series called Introduction to Jupyter. If you have any questions, leave them as a comment on this video or contact me on Twitter at Twisted Hardware. Thank you for watching, and I hope to see you next time.